I didn't indicate it was online, what I should do. In case we're being traced or something. All right. We'll start lab 4, which is on modules and reading files, and we'll do a little bit of parsing, some CSV stuff. Any questions before I get going on new material? Okay, so modules. Module is just sort of taking some of your code and putting in a separate file, and then sort of bringing in that file. So let me open my studio. Or my Visual Studio you have access to because people in this department belong to like this alliance or something or other and can download that. But we're not using Visual Studio, we're using Visual Studio Code, and that's free, so anybody can have it on any number of machines they want. And it's pretty good. I don't know about Chrome, but I've seen it installed on Macs and Windows. So, all right, here we go. My stat. So previously we dealt with functions, and so modules are just sort of a follow-up on functions in a way, in that with functions we could separate some part of our code and define it into a function, and then when we wanted that code, call that function. And one of the purposes was just sort of a logical separation, and another thing was reuse, that those functions might be used by different people or the same coder, different parts of the program. And so modules is just an extension of that idea of that now we're moving this code that we want either just logically separated or to be used by multiple people, we're moving it into a separate file. And then but we have to know how to then invoke it. Okay. So I have the two files here, my stat module and use my stat module. So it's sort of like a function idea in that you know, you have the function and you have the calling of the function. So now I have the module and the using of the module. Okay. So let's look at the module, and we sort of already know this. I just took my my stats function definition with my star args, and I'm creating my dictionary, and I'm going to send back my dictionary, and did a few statistical measures along the way and added them to my dictionary. So that's just all what we did previously. We defined a function that took in some arguments and did some statistics on those arguments. But now I've just separated that definition of my function that generates statistics, and I've separated it into a separate file. And now here I want to use that file, and here's how I do that. Okay, so my stat module had the function definition stats in it, and now here's me using it. So this is just some comment. So in line 7, I am importing that file, and I'm giving it a name. So I'm going to call it the stat underscore module, and then whenever I can get the different things I have in that module, I just tap it. Yeah, I only have one thing in that module, one function definition. But here's me sort of announcing that I'm going to use this other thing. So my stat module, and then this is just as is a word we use in computer science often to sort of rename something. So I won't refer to it by its full name, but by this name. And okay, so what else am I doing here? So I am saying, I'm also interested in this like underscore underscore name thing that we saw appearing in we called something main. And so we said that if this was main, then call main or something like that. And this is more work with this. Now that we have multiple files, this name thing will make a little bit more sense. And the question with this name thing is, what file do I start in? And sort of where does my sort of execution of code begin? So my execution of code is going to begin in this file called use my stat module. Then I'm going to go over to the module and run that code, and then I'm going to come back. So I'm printing out format the name and format the name. So this was before I go. I print it out while I'm over there. I printed it out while I'm over there. So this was added to my function from 2 days ago. So I'm printing the name over in the module. So this is where I start. So I'm going to say what the name is, and then I'm going to call the module. And so it's going to print out its name while we're in the module. And then when I return, I'm going to print the name again. So that's just going to tell us what's going on with this underscore underscore name thing. And it's a way that Python has built in to say, where are we? Are we in the main program where we started, or are we in some file that got called by that file? So this was the first time it's going to be something other than main. So I was using it because it gets used a lot, but I wasn't printing it out because you never saw it be anything other than main. Now we will. Okay. So 7 is me announcing that I'm going to use stuff from another file. 10 is just me doing this name thing while I'm still here in this file. I'm establishing a set of scores and are going to be my data. In 13, I'm going over to stat underscore mod, which is what I called my module, and using my stat functions, I'm sending it my scores. That function was set up, as you recall, with the stars. So when I call it with the star. And so I'm sending over the data. It is, while we're over there, in addition to calculating the statistical quantities, we're printing out the name. And then we come back and I'm printing out the result, which is a dictionary. And then I'm printing out a part of the dictionary. So other than all of this, I did some separating and I sort of printed out this thing called name a few times. Otherwise, it's what we did the previous time. Okay, so let's run this sucker. All right. All right. So here we are. Before we go to the module, the name is main. Because that's our main, that's where we started. Where we started to execute code is called main. So it doesn't get its own name. It's not called use my stat module. They want to distinguish it as where we started. So that was, instead of having its file name, it has the name main. Now I'm over in the module. The module's not main. Then that module is just a function definition. It doesn't ever execute until it's called. But since it's in a file that is not main, it picks up a different name and it is given the name of the file. Then I return and now I'm back to the thing that called, and so that's main. So I was in the main program. I was not in the main program. I'm back in the main program. So that should give you some idea what this underscore name thing does. Here are the results of my statistical function, which was a dictionary. And then here is me showing just one value from one value from within the dictionary. Okay, so this is me separating my code into now a module. Maybe a step above a function, but the same sort of idea of some separation of code, and you have to be called and used. Questions. All right. So next. So that was, so now there are lots and lots. I'm going to show you maybe 4 or 5, but there are tons of Python modules. It's an open source language. All sorts of people are writing things all the time. And then there are sort of standard modules and it becomes sort of a standard part of the language. There are other modules that are not standard, but you know, somebody might have them up on GitHub or something. So there are all kinds of modules for you to use. I'm going to show you some of the standard ones. The standard ones mean that I can just call them by name and I don't have to go myself and explicitly grab the file. So the module I just showed you a minute ago was non-standard. I wrote it. And so I needed the file. I needed to put that file next to the other file. But for standard modules, I can call them by their name and Python knows where they are. If it's a non-standard module, you're going to have to work to make it a little bit more like the first case. Okay. So some standard modules. Okay, so that should be in downloads. Some standard modules, there it is. Okay, so what modules am I going to be using here? So I'm importing, that's what we're importing, modules. So there's a module called system with some information about your system. And so I'm just printing out sys module, and then there are some various things that the system module knows. And so I'm saying, give me the system path. One of the things the system knows is the path. There's a architectural thing about how numbers are stored, whether they're stored little endian or big endian. That is the byte order. And that's something that the system module can figure out about your computer. It can figure out the platform. So let's run that and just look at the top, and then we'll see more. Yeah, that's something that way at the end, I have something that opens up a browser. So that's why that happened. Okay, so here we are. That was the average, that was the old stuff. Okay, so here is the system module, here's the path. This is the path of where path is a bunch of things, and this is where sort of program, where we will be looking for code to run. So we'll look here where there's, because that's where the actual code that we are running is running. And then there are other files. Where is Python? It's in this Anaconda thing. And so this seems to be mostly Python things. So these are sort of places on your system that Python knows about. So that is what path is. A little endian is sort of how if you have the standard unit of memory is a byte, which is 8 bits, but our variables are more like 32 or 64 bits. And so they take a number of bytes, and then the question is, what order do you put the bytes in? So I have to break up a number into bytes, and am I going to put the small bytes first or the big bytes first? That's what this is about, and that's telling us that we do the little, and that this is a Win32 system. So that was information that the system module has. I don't do a lot with the system module, frankly, but it's there, so I'm showing it too. There's a math module to get standard math things out. Here I'm getting 6 factorial and log base 2 of 26, because everybody wants to know that. And so that was 720 was 6 factorial, and 4.7 was log base 2 of 26. Okay. There's a date time module, which will tell me information about the date and time. And so here is just me doing a date time date today. And that was just date today. Here's date time today. Here's me setting a variable now equal to the date. And a date time is usually a fairly complicated thing. And there are all sorts of information packed into it, like what year is it, and what month is it, and what day of the month is it, and what day of the year is it, and all sorts of things like that. And is it Thursday? And so that's all packed into this date time module. So here is today's date, year, month, day. Here's the date and time. And then I ask for the type, and that sort of gives me all of the, that tells me that it is an object. And then the dir tells me like what are the properties of the object. So 33 told me that it was a class that I have, and I have an object of the class date time. So that is that's the class of this date time thing. And then I say with so that was the type, sorry, and then 34 is this dir is going to tell me the sort of properties that are in that object. And there's a big set of them. And some of them have this underscore, and some of them have just simple names. And UTC is about a thing that has something to do with times. You can see seconds. ISO weekday. So ISO is a standardized format out there in the world. And then I said, what is the weekday? And that's a 3. That might be the 3. So I guess it's starting on Monday and 0 based. I guess that makes sense. If Monday is 0, and then Thursday would be a 3, right? So you never know with these things what day they start on. Are they 0 based or are they 1 based? And where do they start? Do they start on Sunday or do they start on Monday? This seems to start on Monday and be 0 based. Okay. Date times are confusing. But there is a module that gives you all sorts of information. OS. This is a module I use a fair amount of. This is telling me some operating system information. And I use to figure out where am I, and maybe to move me to where I want to be. So this is of the modules I've been playing with so far. This one is within Python, one I will use a lot. you can do, Python's very powerful. Python can do sort of like administrative things on the computer. It can run websites. We'll do the latter. We won't do the former. So that's why it has all these modules, because it's like all over the place and can do all sorts of things. But in this class, I won't have use for most of the modules, but I will have use for the OS module. 42 is going to, this CW get means to, go out and get something, and then CWD is current working directory. So that's going to tell me where in my directory system, where in my file system that this program thinks it is. And it's not necessarily where the code is. And that's important for you to realize, is that where the program runs. So I'm in a terminal right now, and where the terminal is and where the code is are not necessarily the same. And sometimes I need to make them the same. So that's where I need to work with this OS. So this is going to get current working directory. It's going to tell me where I am. Get logon is going to tell me who's running this program. A path is going to say, here is file. File is going to be this file that I'm in, and I'm going to find the path, the real path of it. It's going to tell me I'm on a Windows system. It's going to tell me it's C:\user blum downloads something. So that's where my file is. Okay. So I can find, but a file name, this is going to include a file name. If I say directory name, it's going to stop short of the file name. Okay, so here's the piece that I really like and find important. Sorry. Okay, so I'm using this OS module. Let's go into the inner parentheses and work our way out. I am finding where file refers to this file with the code in it. And I'm finding out where it's located. Then I'm finding out its directory name. So I'm peeling off the name of the actual file. And then my outermost thing is I am changing CHDIR. I am changing the directory. So I am in a terminal. This program's running in a terminal, and I am changing the directory of the terminal to the directory of the file. That's what I'm doing here. And then I'm printing out the current working directory, and it presumably, if it wasn't, if 42 wasn't located where the file was, by 52, it should be. We should be the directory that the terminal is pointing to should be, or at least in terms of the running of the program should think it's in the same place as the file. That's the purpose of this code. Let's see what's down here. So the current working directory was downloads, and the person running the program was me, Blum. And here's my program, users Blum download some standard modules py. Where was the program located? Go away. Get rid of the file name and just keep the folder. And then I changed the directory. It started off just in downloads, and I've moved it into that folder. So now the execution, the Python executing, and this where the file is are sort of synchronized. That's more time, but they're in the same place. Okay. And then I say, where am I at here? So that was 52. I tried to make a directory called poop. And the reason I'm trying to make a directory called poop is because if I run this program again, there's already a directory called poop and it will fail. So if there is no directory named poop, it will create one. Make dir is make a directory. But if there is already some poop, it will fail. And then I go to the except. And it says, that's why it says print out the poop folder already exists. And then I say list what's in the directory. And that's this list dir. And so there it is, poop and standard modules, that's what's in the directory. And that creates, as we see, a list. So I could say what's in the directory and I could loop through it and do different things. So I could do lots of system stuff here. This one, this 50 is what I find useful. To make myself, make where I'm executing code and where the file is located agree. And then here's my last standard module in this little program anyway. There's a web browser module, and I can use it to open, give it a URL and open up the page. Okay, so that's just some standard modules, give you some idea. So I can make Python do stuff out to the web. We're eventually going to do a lot of that. And we're going to have it go between the sort of server side and the client side. That will be an important purpose for us in this class. It can do very sort of low level sort of networky stuff and know what users are, know what the users are, and know what the file system is, and all sorts of things like that, and all sorts of things in between. And it knows math and it knows statistics. I didn't use the statistics module, but there is one. There's all kinds of modules. All right. So, and I don't have, I showed you what was in my downloads and there wasn't much. So these standard modules, you just invoke their name. Whereas again, if it's somebody's module, then it's not standard and you're just using it, or if it's your module, then those files have to be sort of in the same vicinity. Okay. Now what? So my stat was my own module. These were the standard modules. Now I'm going to read a file. Okay. So I'm reading a file. And I put this Robert Frost poem, which is in a text file. I put it right next to it. It's the sibling of my Python. So here's where I'm using that OS module that I just talked about. I am changing the directory to match up. So I am executing where the my position of execution matches the Python file. And I'm opening the file frostpoem.txt, and I'm opening it for reading. I'm going to read it. Okay. So that's some big message. Okay, so I am reading the poem. So F was my file that was open for reading. That doesn't read it, but that gets it ready to be read. Here's me in 25 reading the poem all at once. I'm closing the stream. I'm closing my connection to the file. And then I'm printing out the poem. And I'm printing a long, so I'm going to clear it up down here. Okay, so that's the first. I'm just going to read several different ways. So that my first read is establish the file, read the file, which is all at once, close the file, print out the poem, and then print a line. So I keep reading it over and over again, but this was the first one. Here's the first one. So just slapping out the poem. And then here's the line. Okay, here's my second read. I bring in the keyword with, and I say with the file open, and then I read it, and then I print it. Okay. So if I use the word with, that says that while this, everything that's indented. So remember that, like when you indent something, it belongs to a block. Say if we had an if, the code we wanted to do if the condition was true was indented. If we had a for loop or a while loop, the code that we wanted repeated was indented. So everything we want to do while this file is open gets indented. So while the file is open, I'm reading the file. Then on 36, I'm outdented. That means I'm done with this file and it will close it for me. So I don't have to close it because that's implied now. So before, it wasn't clear what all I was going to do or not do with the file open, so I was responsible for closing it. Now that I've defined this indented block with my keyword with, it knows when I'm done with the file, and it will do the cleaning up for me rather than me explicitly closing it. Okay, and then I can, just to make the printing different, I put it into uppercase. So I read the file again all at once. I put it into uppercase and I printed it out in uppercase. So there is my poem down there in uppercase. So that was version 2 of reading. That read all the stuff into one thing. There was one big blob of text. Now what I'm going to do is make a list of individual lines. So I'm going to read the file all at once, but what my result is going to be a list, think array, but it's going to be a list of lines. So before I read in one great big string that might have had some return characters in it. Now I'm reading sort of separate, I'm reading them all at once, but I'm going to be able to treat the lines separately. So I read the lines, I'm reading the lines, which is creating a list of lines. I had my random. We imported random before. I like random stuff, so there it is. And random has this method called shuffle, and it rearranged the lines of the poem. And then this is me seeing what's at the end of the line. Okay, so poem 30, that's a line of my poem. Now it's shuffled up, so I don't necessarily know it's the first line, but it's the new first line. And then instead of making us figure out how many characters in the line and figure out what's the index of the last character, we can say -1, and that just does like a weird wrapping around thing. So -1 is the end of the line. So I have an array of lines of poems, and each line of a poem is a string, and I can treat that also as a list of characters. And if I put in the index of -1, that's the last index. So this is the last character of my first line. Poem 30, the 0 means it's my first line, but I've shuffled up the poem, so you know who knows what the first line is now, but it's the first line. And -1 means means it's the last character. And then what crazy crap am I doing here, and why am I doing it? Ord is going to figure out the number that's corresponding to the letter. So, you know, in computers, every character really is a number. Capital A is a 65. Every good nerd knows that. And Ord is finding like the ASCII, the number that corresponds to this character. And then I'm converting it to a string so I can add it to another string. And I want to see that what the character was. And I'm telling you what it was. It was a 10, which means it's a line feed. So while they divided the poem up into lines, there's still an end of line character hanging on the end. So if I were to print out the lines and my normal print puts something on its own line, and I have an end of line, a new line character as part of it, if I did that, I'd be skipping every other space. Every other line would be blank. So this was me figuring out that there was a line feed character at the end. And so here, okay, so here I am looping through the lines of the poem. So poem 3 was a list of lines of the poem. I'm looping through it. So each element of my list is a line. I'm putting it now in all lowercase. And I'm saying in my print statement, I'm saying the end is quote, quote. That prevents me, that suppresses the end of a line character that's associated with print, because the line already has its own end of line character. I could do some work to get rid of that end of line character. That's a different approach I could do. I could do some kind of like a replace it with nothing. But that's not what I did. I just decided to print it. But when I was printing it, to take away the end of the new line character associated with print, so I didn't have two of them. Well, that's fun. Now, here's my question, and I don't know the answer, but if you are the super nerd, maybe you'll figure it out. Linux systems and Windows systems sort of like disagree on how lines end. So if I ran this program, if I wrote the poem, you know, over on a Linux machine and ran this code over on a Linux machine, would I still have an end of line character? I don't know the answer to that, but maybe I'll be brave and check it. I do have a Linux system going right now, so maybe I will check it, but I'll probably forget. Anyway, so that's what that was. Okay. So the last ASCII character, it says, oh, I'm saying it was, making a liar out of me here. I said it was a 10, and here they say it was a 46. So I'll have to play again. So I thought it was a 10. Before when I did it, it was a 10. Now it's telling me it's a 46. So interesting. Let me run it again. Fun. Clear, clear. There it is, a 10. Okay. So I got 10 one time and 46 another time. Interesting. All right. I need to play a little bit more. Okay. So fourth and last time I'm reading this file. There are many ways to read a file. That's the point of this crazy program. With open frost poem.txt, open for reading, I'm calling it F4. Now I'm going to read one line at a time. In number 3, I read the whole file at once and broke it into lines. In this case, I'm reading it one line at a time. So I have in for, I say, I'm looping through the lines in this program. I'm asking if the line, when after it's stripped, if there's anything there, then I'm going to do this stuff. I'm going to print out the line. Otherwise, I'll skip it. So if it's a blank line, it will skip it. So I think there's some stanzas or something like that. There's some break in the stanzas. So there's some blank lines. And so this is getting, this last version is getting rid of the blank lines. And I'm also, you can see I'm in a loop reading line by line because I'm putting in some counter, and I'm explicitly myself incrementing this counter. So I'm printing a line and incrementing my counter and printing the next line, including my variable, my counting variable. So you can see that I've read this thing one line at a time. So I can read it all at once. I can read it all at once, but break it into line, have the computer break it into line for me, or I can read it one line at a time. And I can probably do more. I can probably even read it like one byte at a time or something crazy, but I don't want to. All right, questions. All right, almost done. So I read a file. I'm going to read a comma separated values file, a CSV file, and I'm going to parse it. I'm going to split it up. And that's pretty much what then you're going to have to do. Okay, so here's my order. Here's the file I'm reading. It's a fascinating file. It says pencils, comma, 0.15, comma, 150. That's going to be that this person's going to be ordering pencils, that they're 15 cents a piece, and they want 150 of them. So it's just somebody's order for some school supplies. And they're ordering pens and they're ordering rulers. Okay. All right. I am doing, I told you I love this thing. Here's my operating system file thing, my operating system module that says I'm going to be interacting with the file, the CSV file, and I want to make sure that where I'm executing and where I am, where my code is and where I'm executing and where I'm reading the file, that they're all in agreement. That's what this is all about. I don't yet have objects. That's like the next lesson, I think, is objects. But I don't have objects yet, so I'm going to have parallel lists. So I'm going to have a list of items. I'm going to have a list of prices. I'm going to have a list of numbers of items that somebody ordered. Okay, we'll do better, but this is how we're doing it for now. I'm going to with open order CSV read. So I'm reading the file. I call that file F. I'm going to do it line by line. So I'm doing the last kind, the fourth kind of read from the previous. I have some sum because I want to know how much money they spent. Okay, I have people who copy me so blindly that they will have this sum no matter what the hell program they're writing. The sum is because I'm figuring out how much to charge somebody for their school supply order. That's why I'm summing. Not every program will have a sum, but some of you will put it in every program because that's the way you are. Okay. So here is us looping through the lines in the file. Here's me, again, checking to make sure there are no blank lines. And then it can work a little bit differently if you have headers. So I didn't have headers. you might have to read the first line separately if your data has headers. My data didn't have any headers. So that's something you got to be looking out for, but it wasn't here in this case. Our strip is getting rid of any sort of extra spaces or anything that might be on the ends. Split takes a delimiter. The delimiter in this case was a comma. Will it always be a comma? No. But often it's a comma, and the name CSV implies it's a comma, but it's not always a comma. But this breaks it up into 3 pieces. So there'll be, after you split, there'll be pencils, there'll be 0.15, and there'll be 150. I will take the first thing, which was pencils, and I'll add it to my items list. I'll take the second thing, which was 0.15. I'm going to cast it as a float so I can do math, and I'm going to add it to my prices. I'm going to take the third thing, which was 150 pencils. I'm going to cast it as an integer and add it to my list of numbers. And then I'm going to add the price times the number that they added and can add that to my sum. That's my sort of subtotal. And then ultimately, when I'm done the loop, my total. Okay. Will they always be a string, a float, and an int? No. Same thing as I won't always be summing. It won't always be string, int, float. It might be int, int, int. It might be string, float, float. It might be string, string, int, string, int, string, string, int. You got to look at the file and do what makes sense for your program, not just copy blindly. Okay, so this is me finding out what the items were, what the prices were, what the numbers ordered were, and keeping track of how much they owe. All right, so now I want to print things out. So I'm looping through the items. And I have this very fancy formatted print. The first thing I print, every curly bracket represents something I'm going to print. So I'm going to print 1, 2, 3, 4, 5 things. And here they are. There's my counter. I made it I+1 because the normal counting starts at 0 for lists. But I don't want to display a user a 0. I want to display for them a 1. So that's going to make it 1, 2, 3. Here's how many they ordered, numbers. Here's what they ordered, pencils. Here's the price of it, 0.15, 15 cents for a pencil. And then here's numbers times price. So that's the subtotal for whatever they ordered for pencils. There's also in here some formatting. So this colon greater than 4 says use 4 spaces for that and write justify. This colon less than 10 means use 10 spaces and left justify. The colon 4.2f says use a total of 4 spaces and 2 of them for the fraction because it's money. And greater than 7.2f says use up to 7 spaces for the entire thing, write justify, and use 2 numbers for the fraction. And that was all a big comment. And then down here, I have a separate line that says that the total is sum. All right, let's clear. And clear again, just to be sure, and then run this. And then I print out also the arrays. So this is your order was, item 1 was 150 pencils at 0.15, and that was 22.50, and 250 pens at 45, that was 112.50, and 55 rulers. 45, and that was 79, 74, 75. And the total was 214.75. I didn't bother lining that up because I was lazy. And then I just, at the bottom, I just printed out all my arrays to just once again see the data. I said array, I meant list. I'm in Python. Okay, that's basically, you have to modify this program. But you also have to ask some ifs. Okay, so blah, blah, what do you have to do? Eventually, we're going to get out of this COVID phase. I'm going to have to change this lab, but still applies. Okay. So employees are supposed to fill out a survey. I think now it's 5 instead of 6, but anyway, there are some questions about that you are asked. Do you have to do anything with the questions? No, ignore the questions. I'm just putting them there for context. Here are the results of the survey. These are the answers to the yes, no questions. Okay. So here is, I spelled my own email, blum@lasalle.edu. One means I'm coming to campus, and all the other things mean, no, I don't have COVID. I don't have blue lips, and I don't have the fever, et cetera, et cetera. So I'm allowed to come to campus. And the CUI, she's not coming to campus, so you don't care. Smith said he was going to come to campus and then answered one of the questions yes. And so we have to tell Smith not to come to campus. So that's what we have to do. If the first answer is yes or 1 and all the other answers are 0, then they're fine. But anybody who answered a 1 and then followed by anything else, we have to sort of pull their name to the side so we can yell at them not to come to campus. So that's what your little program does. So the main thing will be read the file just like the order, read the CSV file, break it up into pieces, and then you've got also some questions to ask. So it's a throwback to complicated ifs, but otherwise, okay. Any questions for the recording? Okay, so I'm done recording.